first, my dad brought home this 3D printer. We had no idea what it was. And so we decided to try and build it. So we spent hours and hours sitting at a table, me and my brothers, trying to build the 3D printer. And so in the end, we just couldn't wait to see what we had printed. And so we tried to print this little dice block. And it didn't come out that well, but it was our first 3D printer, and that's kind of what inspired me to start 3D printing. So to start off, instead of just jumping right into 3D printing, the way that you make things is manufacturing. So to manufacture something is how you make, like, let's just say a toy. You typically get it from a factory, which they manufacture everything. And that's typically subtractive manufacturing, which is over there, which means that you take a block and you cut away at it or carve into it, and that's how you form your object. 3D printing is additive manufacturing, which means that by doing it, you add layers and layers. And so adding the layers helps because you're reducing the amount of waste, whereas subtractive, whatever you cut away, that's all waste. And subtractive can be faster and cheaper just because the materials are widely all over the place. So the machines that actually cut away at subtractive manufacturing are everywhere, whereas 3D printers, they're not quite everywhere yet. Typically, in a 3D printer, you print with plastic, and that's how it prints the layers by layers instead of ink. 3D printing is a way of layering materials, typically plastic, to form an object that you could design or that you could get off a website. So what's it actually used for? The number one use, I'd say, is prototyping. So let's say you wanted to make something like a science fair project, which is something I did. You can just print it, and then if you just need to change one small part of it, you can just reprint it again. Whereas if you would, before, you'd have to mail it somewhere, you design, and you'd have to wait a week to get it all the way back again. Now you can just fastly print it again, and then you immediately have it. Another use for it is creating cars or homes. So cars, like let's say you wanted a unique sporty car just to your customization. So you can print it exactly how you want. And typically they're printed out of like plastic, so it's actually even more durable than most metals today because the plastic they've engineered is very, very strong, and it's also a lot lighter, so you get a lot better mileage if you have a 3D printed car than a regular car. Also homes, so you can pretty much print it out of any material. So let's say if you wanted to help out a third world country, it's a lot more affordable, and you can even print it in mud if you wanted to this house. And it'd be a lot more sturdier than just like taking your hands and just like building this house, whereas you can just print it right out. Another use is medical. So pretty much people have printed prosthetics and other parts. So let's say you needed a hand or something, a child needs a hand. It can be very expensive to go through a doctor's office or any other sort of medical 3D printing. But if you just do it yourself, you can customize it and you can change it exactly how you want. Another use that's being currently worked with is 3D printing tissue or organ samples. So they're working on creating organs so that if people need organ transplants, then you can use a 3D printed organ instead of having to have someone donate for you. So STEAM or STEM, which is science, technology, engineering, art, and math, people in this job or people who go to STEAM or STEM schools see a lot of 3D printing. Because who has the most innovative minds? They're kids. Kids have the most creative minds out there. They can imagine anything. So what if they could just print it right there, right then? So that's what 3D printers allow them to do. So what type of materials can you print in? 3D printers don't print in ink like a normal 2D printer. They actually print in, the most common consumer level is plastic. So you can print in plastic and then it's quite fast and very affordable. So the types of plastic that you can print in are ABS, PLA, and SLA. PLA is a plant-based plastic, and it's very like usable in the environment, so it helps out the environment a lot. ABS is a more durable hard plastic that you could use for like prototyping or use something that would be like if you drop it, it's not going to break at all. And then SLA is typically a resin plastic, which means it's like liquid plastic. And so once you print it, it goes down and it gets each layer and hardens it, and it's a lot harder and faster versus like melting, because the way ABS and PLA works is that the filament or pellets go through and it has to take the already hard plastic and turn it to liquid and then harden it again. SLA is already liquid, you just gotta go down and harden it. Metal 3D printers, they're a little bit more expensive than plastic 3D printers, so it's harder to find them in consumer level places or houses or small businesses because the extruder gets really, really hot. So the typical temperature for a plastic printer is 230 degrees Celsius, so that's still very, very high. But metal, it's insanely high, so it's a lot harder to maintain with temperature and stuff. There's also, if you don't want full-on metal, there's something called metal PLA, which is actually a metal plastic. So it's plastic, but it looks has the same qualities of metal. So you can fake people and say that it's metal, but it's really plastic. And then my favorite, of course, is the chocolate and candy 3D printers, because you can put whatever dessert you want, you can make your face on it, you can customize it exactly how you want. Food is another great thing. It's fairly new, but people can print. You can print pasta, you can print meat, you can print pizza, and you can print in whatever shape. So let's say we're doing an event and you're trying to do a dog fundraiser or something. You can print all your food dog shaped or whatever shape you want. The fifth type is PVA, and PVA is a plastic, sort of, that goes in and as support material. So let's say you're building something like a fridge, and usually the plastic would dip down because there's nothing to hold it in place. So if you printed support material out of plastic, typically the plastic's pretty hard to get off because it's made out of the same material. So if you use PVA, you just drop it in water and immediately the PVA dissolves. So then once it dissolves, then you're left with whatever object you have. So what's the 3D printing process? It's design, export, slice, and print. The number one way I'd say is to make your own design. This way you can customize it exactly how you want. So a few free types are Tinkercad, which is really, really easy. Tinkercad's a really, really easy program to use, like super easy. Like any kid can do it whatsoever. Another one is SketchUp. So SketchUp is okay, it's not that hard, but it's typically used more for just designs and finished designs instead of 3D printing the actual item. And then there's Blender, which I'm sure everyone's heard of Blender at some point or another. And Blender is typically used for animations and stuff, but you can create whatever sort of design or figure you want to create, and then you can export it to a 3D file. You can also get designs off the internet. So Thingiverse, I'd say, is the best free design software that you can get, where it's got thousands to millions of designs that you can just 3D print immediately once you download them. The next step is exporting. So you take your design and then you export it. You typically want to export a design as an STL file because that's the most widely used file in a 3D printer, especially at consumer level. The other common one is OBJ, so object file, and so pretty much you just want to export it so that you have the final file. After that, you're going to want to slice it. So a few free programs of slicing are Cura, Slicer, SkinForge, and NetFab. And then some not so free ones, but are still amazing at slicing, are Simplify 3D, Autodesk, and then MakerBot. So if you have a MakerBot, you get the MakerBot software, but it only works on MakerBots. And the output of slicing is a G-code. So pretty much you turn it from an STL file to a G-code. A G-code file is pretty much if you take a map. It's going to be a map for every layer that you have. So let's say you have 2,000 layers in this object. It's going to be a map of where the 3D printer needs to print every single layer. So it's a fairly large file. This diagram shows exactly what types of 3D printers, the types of slicing shows and how it's different on each one. And then the final and my favorite step is printing it. So then you have your wonderful object at the end. Thank you for listening.